It probably won't surprise you that as much as I want to be interesting and informative, this YouTube channel to me is also a playground in which I'm learning various aspects of video production. The fact that color correction tools in some video editing tools like DaVinci Resolve operate on 4 color channels, YRGB, made me scratch my head. Now that I understand, I want to share my findings in this quick video. Color spaces and color gamuts are huge topics that deserve their own much longer video. But just for a quick comment, RGB and RGB aren't always equal. Colors are complicated, but this video is not about it. For now, let's just agree that pretty much every color video display works in some form of an RGB color space. If you look closely, you can see individual red, green and blue dots that make up the picture, and when combined together, look like white from a distance. And the RGB sliders in your color picker more or less control the intensity of each of those 3 subpixels. In the context of an image, that's called color channels or components. If you open the curves tool in something like Photoshop or GIMP, you can manipulate the transfer function of pixel values. The x-axis is the input, the y-axis is the output. For example, you can specify an S-curve that will darken the dark areas but lighten the light areas, increasing the contrast without losing any detail. For a grayscale image, it ends there, but for a full color one, you can apply separate curves for each of the red, green and blue channels. Aside from that, there is also a value channel which applies the curve to each 3 equally. In GIMP, that's applied as a last step after the separate channel curves, but usually you'd either use the value one or the 3 per channel ones, not both. In video, a different representation is often used, called YUV or YCBCR among other terms, each technically distinct but mostly referring to the same idea. It's a linear transformation of the RGB space. Y refers to luminance, an average of each of the RGB channels weighted with an approximation of human vision sensitivity to each of those shades. The other 2 channels are the difference between blue and Y and between red and Y. Those can be called CBCR, PBPR, DBDR or U and V, depending on how they are normalized and represented for storage and transmission. Together, they are called chrominance, and this separation allows them to be stored and processed in lower quality, as human vision isn't as sensitive to color as it is to brightness. And there's no need for a green difference channel, because it can be implied from the luminance and the other 2. We had 3 degrees of freedom with RGB, so it wouldn't make sense to introduce a 4th channel. But if you go to the curves panel in DaVinci Resolve, it's neither RGB or YCBCR. It's... At first, you might think that it works like in GIMP, but let me mess up the RGB channels. It changes the colors, but somehow not the luminance. And to get all colors processed in the same way, it's not the matter of changing the Y channel or all 3 of RGB like in GIMP. You need to gank all 4. It obviously separates the luminance information somehow, while exposing chrominance as RGB, rather than something like CBCR. And they aren't color difference signals either, because the input values aren't concentrated around the middle. The x-axis clearly refers to the original RGB values. So what's going on? After a bit of head scratching, I figured it out. Here's the signal flow. Let's suppose we start with RGB signals. Let's convert them to YCBCR. Then here's Resolve's curves process. We put the original RGB, but also the converted Y channel as independent channels. Then we convert the processed RGB channels to YCBCR again, but discard the Y and replace it with the one from the Y curve. After converting that back to RGB, we get the processed image. We can replicate this process in GIMP by duplicating the processed image as a new layer, converting that layer to grayscale, and changing its blending mode to LCH lightness. Now, if we apply curves to the full color layer, it will work like Resolve's RGB channels. Manipulating the monochrome layer is like Resolve's Y channel. The results aren't 100% identical because of the differences in color space conversions and also the way out-of-range values are handled. But this is the idea. The lift, gamma, and gain adjustments on the primary stub also operate in the YRGB space, and the idea is the same. Note that while having 4 curves is more powerful in most cases, some 3 curve settings may be impossible to replicate in this representation. For example, cleanly isolating only one of the RGB channels. In any case, that's it for today. If you, like me, also had trouble understanding the math behind 4 color channels, I hope that helped.